Yes, good afternoon, everybody. Today we'll be welcome to this session of sustainable construction methods. Today we'll be seeing this topic bridges. Basically, what do you mean by bridge, and what are the different types of bridges, and what are the uses, and what is the construction of a bridge that we'll be seeing basically in this topic today. Let us see here. Introduction. Bridge is a structure. You can just see here. Built as a structure built to span physical obstacles such as a body of water, valley, or road for the purpose of providing passage over the obstacle without closing the gap below. Basically, why do we come up with a bridge, or why do we construct a bridges? Basically, we want a smooth flow of traffic above the bridge without creating any obstacles at the bottom. Bridge building is not a new science. The sophistication in the bridge building technology has been developing since the human civilization. You can just see this figure on to the left. You can just see a simple bridge here. You have to just cross a small canal, as you can see, a small river body here, a water body here. So just what you have done is you have put a big bamboo here, a big huge log here, and on the top of the log you have put uh, this wooden planks, you can see, wherein the people can uh, cross easily. They can step on it and cross easily. Whereas the right side, you can see this bridge which has been constructed, and this is a concrete bridge, and you can see the abutments and the piers which have been placed at the bottom. So basically, the bridge is that structure which provides you a passage to for a free flow without creating any obstacle at the bottom. You can see what are the importance of bridges. It connects difficult terrains. Difficult terrains can be connected. You must have seen at different places, hilly areas also. You must have seen where we want to get connected from one place to the other place. At the in those conditions also, bridge play a very important role there. Easy trade and transportation of goods. Sometimes what happens is, if you don't connect those areas from one side to the other side with a bridge, then the long area can increase the cost of the goods also, and it won't be easy to provide different goods from one place to the other place. So easy trade and transportation of goods also, it serves this need also. It reduces traveling time. You can see it reduces traveling time if you don't come up with a bridge. Sometimes what happen, because if you are interconnected, by if you are connected, you want to send some goods from one state to the other state. If you don't have any bridges in between which can surpass the traffic of the city, then and there this hurdle comes where the traffic time is increased because of the long queues and everything. So it reduces travel time also. You can see it is very good in for military use also. From one place to the other place, it can be connected with the bridges. The military use whatever is needed, as it can be transported from one place to the other place. Political and economic importance. Yes, political importance also, it connects different states and different countries also. Whereas even the economic importance also it has. It improves the economy of the country or a state also, if there is good connectivity from one place to the other place with a bridge in between them. Less emission due to displacement. There is less emission also, because there is not a lot of displacement, so less emission is also there. Let us see what are the components of the bridge. You can just see here components of the bridge here. From the bottom, if you see your typical bridge components, you can see this is the steel pile has also been inserted inside, depending on the type of the soil. Yes, piles also are inserted inside. You can see here batter is also there, which gives a support to these piles. Footing, this is the footing which have been placed onto the piles. Okay, both the sides. You can see this is the column which is taking the whole load here. Let us see on the top what all comes on the top here. See, you can see over this column you have the spear or a pier cap, you can see as well, and this pier cap is on that the superstructure is resting on this pier cap. You can see here elastomeric bearing is also there, which takes the shocks coming onto the slab. Bridge slab, it takes this bearing also. Bearing structure is also there. Bridge drain is also provided. If there is some rainwater or any other water, it has to be drained, or else then it will damage the upper surface course or the different courses of the bridge. Steel beams are also being provided to give the supports here. You can see you have bearing surface also on top of this bridge, top of the the last surface on the bridge. You have concrete slab also. This concrete slab is resting on these columns, I sections, as you can see. These I sections are again resting onto the piers. You can see here F-shaped barrier. You can see here. Let us see what else is there. Construction. This is how it is constructed. You can see this part below. You can see from the pier cap to the column and everything down. It is called a substructure. Whereas above that, above this pier cap, it is called a superstructure. So these are the components of bridge. You can see. You must have seen here. Probably. Let us see what is the classification of bridges here according to the flexibility of the superstructure. What type of superstructure we need and how flexible it should be, depending on that also a bridge is being designed. And then again, according to the position of the bridge floor, what is the position of the bridge floor, where it has to be provided, how should be the floor, all these depending on this also the classification is based on bridges. You can see according to the interspan relations, what type of relations are there between the different spans. Sometimes the span is very huge, where you need to come up with a span wherein you can break it and join it. You can have multiple spans there to reduce to reduce a long girder which has to be placed to resist the traffic flow. According to the form or type of superstructure, what type of superstructure are we going up to, and what is the form of the superstructure? So depending on this, this is how the bridges are classified. Let us see next, loading on bridges. What are the different loads that come onto the bridges? As you can see, dead load, the self weight of the bridge itself is there. The self load is also there. Then you have the live load. Live load, you can just imagine here the vehicle passing from one place to the other place, or any other thing passing over it is called as live load. Beyond sea pressure, you have different pressures acting onto the bridges also. So even that has to be checked. Centrifugal force is also there. Centrifugal force, normally we check this for a normal pavement surface. Also we check for the centrifugal force. Even here on the bridges, we'll have to check for that centrifugal force. Earth pressure is also there. Earth pressure is also exerting its pressure from the bottom. So even this loading also comes onto the bridges. Seismic load, as you can see, we can't estimate what will happen in the future. Basically we'll have to just imagine and assume seismic load will come, and whereas depending on the zone, which zone we are designing this bridge, so seismic load also acts there. Water pressure is also there from the bottom. Water tends to sway the bridge, so even that has to be checked here. Water pressure, sometimes the intensity of the water increases, and because of this there are chances of bridges flowing away. Wind load is also there. High intensity of wind loads also act onto these bridges, so even it should be checked. Thermal forces different, because the bridge is made up of different materials. There are chances of thermal forces also acting on it. So just see planning for a bridge. What we'll have to see for planning of a bridge: sequence and planning. Study the need for the bridge. First thing, you see the sequence. Study the need for the bridge. What do we really need a bridge? That has to be seen first thing. Next, assess traffic requirement. What is the different traffic? If we come up with a bridge, what will be traffic requirement? That has to be assessed beforehand. Location study, where this bridge has to be placed, even that has to be seen very properly, because sometimes what happens, those bridges are placed somewhere not placed properly. Because of that, there will be lot of hurdles there. Study of alternative. If sometimes some location or some access or traffic changes, then we'll have to go for some alternative also. Shortlisting feasible alternative. The alternatives provided should be very short listing. It should not be long serving, because we'll have to just need to go on with some alternative. Developing concept plans for alternatives, including choose of form, materials, span arrangement. Everything has to be checked here before going for a bridge. Preliminary design and costing is, the design has to be checked beforehand, and even the costing has to be finalized beforehand, depending whether this coming up with a new bridge will it be beneficial or not. Evaluation of alternative, the risk analysis, and final choice, and what are the different types of risks involved in constructing this type of bridge. Even that has to be seen here. The risk analysis also has to be done. Finding resources, detailed survey design. We'll have to see what are the resources from where we can get these detailed surveys, and well as the design has to be done beforehand. Implementation including a preparation of bid documents, fixing agency, construction, commissioning. See, implementation is very important, where you have different factors here which can be seen here. You have fixing agency, you have construction and commissioning also. Depending on this, you shouldn't compromise with the material used and the quality of the bridge that has to be designed. You can just see on the left side 3 dimension of structure: scientific dimension, technological dimension, social dimension. Because planning for a bridge, you have to see this type of dimensions also, because scientific and social dimensions and technological dimensions also play a very big role. Let us see aesthetics of bridges. External appearance. The external appearance should be very good. Even this has to be seen while constructing a bridge. Internal view should also be good, and sequential view should also be good. You can just see this bridge here, how good it looks after the lighting has been on here. You can just see a face here, everything. So even this needs to be studied very properly. You just can't go for some sequential view. You just can't go for some elevation. No, it has to be studied differently. Guidelines, beauty and stability is very stable also, and beauty is very good. Bridge and environmental integration, yes, two different sciences intercollide and come up with a solution. That is bridge and environmental integration. Third, material choice. What is the type? Which material has to be used? Even that can be seen here properly. So material choice is also there. Moderate lightings. Lighting shouldn't be so bright that they disturb the driver's view, and they shouldn't be so dim, whereas the house owners and the people living there uh, should not face a problem because of low voltage. So these are the guidelines. This is how, what are the different types of guidelines to be followed while coming up with a bridge. Let us see further. Let us see what is the steel bridge here. Steel is largely used in construction of bridge for short as well as long span. So steel is used for short span as well as long spans also. Basically, it is used in construction. Steel has been recognized as economic option for range of bridges. So steel has been recognized as an economic option. We just can't keep trying because the structure is very huge. We just can't keep trying till the end, like we have three-fourth spans and everything, so it has to be seen. Steel has been recognized as the economic option for range of bridges, for long span bridges, railway bridges, footbridges, and medium span highway bridges. So as you can see, that most of the places steel has been used for depending on the economic option. You can see the world's first class iron bridge was built at Telford in 1779 by Abraham Darby. So the first bridge was built in Telford, that was in 1779. You can just imagine how advanced these people are. Beforehand, about 200 years before, they have come up with a bridge which was first built in Telford. The steel bridges now have proven lifespan extended to well over 100 years. They have also proved that the steel bridges have lifespan more than 100 years also. So we don't have problem with any demolition site or any damage also. Classification of steel bridges, you can see steel bridges are classified according to the type of traffic carried, what type of traffic is being carried, and next the type of main structural system, what structural system will come up. Even this will be finalized beforehand also. The position of the carriageway relative to the main structural system. How is the position of the carriageway? Even this is seen here. Everything has been checked here, or else then there are chances, if there is not proper steel provided here, there are chances of collapsing. So proper steel with proper material is used here, that has to be checked here. You can just see there's a good view of a bridge which is constructed using the steel. You can just see there's rivets here, rivets. You can see the bracing here. So everything has been fixed properly. You can just see a reinforced concrete bridge. RCC bridges are the earliest form of bridges. They are easy to construct. So they are easy to construct. Arches are preferable where bending moment is more, and they are easy to design. So arch bridges are mostly preferable because the bending moment is more there, and they are very easy to design. Let's see site selection for RCC bridge. Straight reach of the stream. It should be constructed at a place where the stream directly gets here and the straight flow is achieved here. Good foundation should be very high. It should be good. It shouldn't require and it shouldn't have some settlements also in future. Well defined firm banks. The what the property loan and everything you get. So well defined banks should provide that. Minimum width of crossing. The width of crossing should also be checked here. It shouldn't be too narrow where the vehicles can't enter onto the bridge. And approaches also is there. Approaches should be provided by clear instructions, whereas the bike can enter as well as exits also, depending on our luck here. You can see here, it's not always possible to provide straight deck when horizontal curves are to be provided. The following design speed is to be considered. See, it is not always we are not fortunate where we can provide straight deck, but sometimes we'll have to go for some horizontal curves also. In that time, all this procedure will be needed by. So design speed, if it is 80, minimum radius in meters should be 300 or 240. You can see a ruling or absolute. Design speed is at 48, hilly country. Ruling should be 120, absolute should be 90. So all this is already given in the code. You don't need to worry. This has been just showed here. Suspension bridge. Let us see what is suspension bridge. A suspension bridge is a type of bridge in which the deck, the load-bearing portion, is hung below suspension cables on vertical suspenders. So what happens is basically this load is being suspended by suspension cables. So basically what happens in the start, you must have seen everybody were providing those services. Then with where this suspension bridge is a unique type of design which has been done in different countries before also. Even we have come up with this type of bridge also. The first suspension bridge was built in 1433 in eastern Bhutan by Tang Tung Gyalpo. You can just see here in 1433 they have come up with this innovation where still we are thinking of coming, where we are still in a suspension, that shall we come up with this topic or no, even that we are in suspension. But there it was built in 1430. Suspension bridge is generally preferred when the span is more than 200 meters. If the span is more than 200 meters, then suspension bridge is required, or 300 meters for light traffic like motors. So that is not possible so easy. There are two types of suspension bridges. One is unstiffened deck type suspension bridge. Other is stiffening girder type suspension bridge. You can just see it. You can just see how this come up is. See, this is the tower, this is the foundation, this is the substructure, this is your column which is going up from here to the top, and this is the main cable which is thick enough, and the towers are you can see they have been marked suspension cables also. You can see here suspension cables they have marked here. Main cable is being marked here, tower has been marked here, tower deck, this is the deck, this is the main cable. So everything is there in proper position where the suspension bridge can withstand everything coming on there. You can see a components of RCC steel and suspension bridges. What is used? Steel cables, concrete or steel deck used as construction materials. In the steel bridge, you can see steel frames and concrete deck. And here reinforced cement concrete. You can just see this figure here. It is nothing different is there. Better to understand earthquake movements than heavier and more rigid bodies. Steel can fully meet the structural requirement, which can even small sections. With small sections also, they use structural sections can be given or the structural requirements can be fulfilled. Arches are preferred where more bending moments occur. In RCC bridge, arches are preferred where more bending moments occur. So here, maintenance cost is high as cable needs to be changed. So maintenance cost is high when the cable needs to be changed. Maintenance against the rusting of steel has been done regularly, which increases the cost of maintenance. So what happens is telling the maintenance can be increased with the increase of cost also. Third, the cost of maintenance is very small. The third person says the cost of maintenance is very small. Let us see why does the bridge fail. Bridge failure. When a bridge collapses, many lives are put at risk. Bridge collapse is one of the most dangerous type of structural failure that can occur. So even this has to be seen after designing the bridge. They shouldn't fall off. The bridge shouldn't collapse, as we don't know what is the exact situation, what will happen because of why. Whatever we can see there, it has been told. So we have to take precautions regarding all these things mentioned here. You can see an earthquake is there, fire is there, boat impact, flood impact, construction accidents, manufacturing defects, design defects, poor maintenance. So all this leads to collapse of the bridge. So a very keen sight is needed here, where the contractor shouldn't push away all works, all bamboos and everything. So even this has to be seen beforehand only. Let us see maintenance of bridges. The bearing of girders should be coated with oil from time to time. So the bearing should be coated from time to time. This is very much important. The floor system of approaches and bridges should be properly maintained. You can see here from where the vehicles are approaching or exiting, the floor system should be properly maintained. The entire drainage system should be inspected for its proper functioning. You must have seen it rains and the water collects onto the bridge only. If you provide a good drainage system, there are chances of water coming up from that owner and directly passing into the owner where he has been planted the tree. The entire drainage system should be inspected for its proper functioning. The movement of foundations, if any, should be carefully inspected, and all attempts should be made to stop such further movement. So what has happened? The there the movement of foundations, this should be checked properly. Basically, the design should be very much easily, and it should be achieved by taking these things into our giving the importance. This can be done. Landmark bridges of India, you can see what are this different good bridges that have come up in India. You can see the Bandra Worli ceiling. You can just see it is connecting from the Bandra to Worli, and just see what all the official name is Rajiv Gandhi ceiling. It carries 8 lanes of traffic. You can just imagine here over a bridge 8 lanes are growing, whereas one lane of traffic is around 3.75 meters. Here you have 8 lanes of traffic. So it is a very huge bridge which is coming up with the 4 lanes of traffic in the either side. You can just see here the Haura Bridge. Official name is Rabindra Setu. It carries 8 lanes of road. The design is cantilever. The length is 705 meter. Width is 21.6 meters, and it was opened on 3rd February 1943. So it is very much important. It is very much important what type of bridge we are coming up, what is the length, what is the width, and what all is needed here. That should be seen here properly. You can just see here, just see how colorful it looks. This is a cantilever time of it. You can see here the Raigad Bridge. You can just check it here. Official name is Raigad, carries rail cum road. It carries railways as well as it is providing passage to roadways also. The design is a truss type of design. Material steel. Length is 1.49 kilometers. So it has been connected. You can just places have been connected because of a bridge wherein you can cross over with the rail as well as the vehicular movement also. Width is 7.31 meters. The width is 7.31 meters. It was opened on 7th June 1963. You can just see here how good this type of bridge has been constructed, where it is providing a very free passage one place to the other place. Now let us see what is the conclusion. Bridge connects destinations. Bridges are assets to mankind and have to last for generations. So these are assets to mankind. They have to last for generations, as the construction of bridges influences the whole ecosystem and changes permanent. So what happens? See, bridge is not a very small structure which can be designed again and again, which can be constructed again and again. No, it requires time to construct it, well as it requires good time for other works to finish. So bridge connects destinations. So this is what is the important thing which has come up with the bridge. Like even if a good uh, even if you have a good state or a good goods you have, but if they are not connected by anything in between, then the goods won't reap you or won't increase the economy of that area. Bridges are assets to mankind and have to last for generations. So they should last for generations, sometimes 100 and 150 years at least, as the construction of bridges influences the whole ecosystem and the change is permanent. So proper planning to adapt the bridge into the natural ecosystem has to be. The proper planning is very much important, where the bridge can be fixed as per the need. The scope of the bridge engineering is ever booming, and technology used in bridge building is also getting sophisticated. So what do we want to say is there is high scope of bridge engineering, as the technology is improving day by day. There are more chances of the bridge building can also be completed very easily. So this all these were taken from these uh, books, as well as you can see these the papers of these books. You can see rest of the internet surfing. What all you have to see the Wikipedia, pbs.org, design.technology, Britannica Steel Construction, uh, Tata Steel Construction.com. So all this can be checked. You can check here. So this is the bridge, how it has been connected from the one place to the other place. Because of this, the vehicle are finding a very good chance. Vehicles are finding very good chance to connect from one place to the other place. Hope the session was clear to you all. I request all of you all to go to this video and please comment in the comment section. I'll be thankful to you all to answer to your questions. Thanks a lot. Thank you.